Hi, and welcome to the 3.2 stoichiometry notes video, limiting reactant, theoretical yield, and percent yield. At this point, you should have a good portion of the notes already covered. What we're going to do in this notes, or I should say copied, what we're going to do in this notes is cover the examples and sort of fill in some of the blanks that you have in your notes. We're going to take this in sort of two steps. With stoichiometry, there's the conceptual, like conceptually, what are you doing? Having that understanding is important. And then the problem solving part. So let's start with the conceptual. If you haven't done so already, take a moment to read over the notes, what you have for these definitions for limiting reactant, excess reactant, theoretical yield, actual yield, and percent yield. Okay, so we're going to look at for the conceptual understanding, we're going to look at a cooking analogy. So in this analogy, we have a recipe for making grilled cheese sandwiches, 2 slices of bread, 1 slice of cheese will make 1 grilled cheese sandwich. So this tells you the ratio, it's a 2-to-1 ratio of bread to cheese, for example, but a 1-to-1 ratio for cheese to grilled cheese, right? And we're just using the coefficients in front to tell us the ratios. So what if you actually have, so this is your recipe, but what if you actually have 12 slices of bread and 7 slices of cheese, and you want to know what's the maximum number, your theoretical yield, of sandwiches you can make? One way you can figure that out is for each ingredient, figure out how many sandwiches each can make. So the 12 slices of bread on their own can make 6 sandwiches. So I do 6s for 6 sandwiches. And the 7 slices of cheese can make 7 sandwiches. So what's the maximum number you can make? Is it going to be the smallest number or the biggest number? Well, technically the maximum you can make will come from the smallest number, the 6 sandwiches, because what happens once you've made those 6 sandwiches? You're going to run out of the 12 slices of bread. You won't have any more bread, so you can't make any more sandwiches. So your maximum number, your maximum amount, your theoretical yield is going to come from that smallest number. And so we would say here our theoretical yield is 6 sandwiches. And the limiting reactant is the bread. I guess you don't need the S there. Let's cross it out. Okay, so that's how we do it conceptually. We follow the same process or same thinking when we are doing it with a chemical reaction. So what does that look like? Just like we did with the bread analogy, first thing is we need a recipe. So we need to balance our reaction equation to get our recipe. And then the next thing that we need to do for each ingredient or reactant, we determine how much product or food we can make. So just like we've determined for the bread how many sandwiches and the cheese, we're going to do that for each reactant. So let's look at this example here. If we have a reaction, A plus B goes to form C and D, right? So A and B react together to make C and D, and it's 1 mole each, okay? So what we would do is we would figure out if we want to know the theoretical yield of product D, even though there are 2 products here, we're only focusing on D. What we would do is we would say, let's say we have 1 gram of A, we would figure out from grams of A how many moles of A. From moles of A, we can figure out moles of D, and from moles of D, we can figure out grams of D. So what we're doing is we're figuring out how many grams of product D can be made from reactant A. We repeat the same process for reactant B. If we had 1 grams of B, we would figure out how many grams of D we can make. And it's the same process as you can see. And then once we have that, we're going to choose the limiting reactant is the one that gives you the least amount of product. So if, for example, the 1 gram of A gave us 4 grams of D, and the 1 gram of B only gave us 2 grams of D, we would say our limiting reactant is B. And our theoretical yield would be 2 grams. Okay, so that's what we would say because it gives us the least amount, just like with the sandwiches. All right, what does that actually look like with a problem? So let's look at a problem. In this problem, we have the reaction where we have 1 mole of PCl5 reacting with 4 moles of H2O. To produce 1 mole of phosphoric acid and 5 moles of hydrochloric acid. And they tell us if 4 grams of PCl5 and 2 grams of H2O react, according to this reaction, what is our limiting reactant and how many grams of HCl can we make? So once again, even though we have two products, the only product we're going to focus on is the HCl. So what would that process look like? So for each reactant, starting with the 4 grams of PCl5, I need to figure out how many grams of HCl I can make. So how do we do that? So I want to go from 4 grams of PCl5 to grams of HCl. Do you know how to map it out? If you do, pause the video now and do that on your paper. Since PCl5 and HCl are different substances, I can't go through them directly if they're both in grams. So the first thing I need to convert is from grams of PCl5 to moles of PCl5. And then once I have the moles of PCl5, I can convert to moles of HCl. So once they're both in moles, I can convert to or from them. And then once I have the moles of HCl, I can convert to grams of HCl. So that's what's going here in the middle. So what does that work actually look like? I'm using dimensional analysis, so I'm multiplying 4 fractions. Also write out your 4 fractions. In the first fraction, you're going to put your given, the 4 grams of PCl5. And you can put it over 1 just to make it a fraction if you would like. Now I want to convert from grams of PCl5 to moles of PCl5. What conversion factor do we use to go from grams to moles? It's the molar mass. And the molar mass of PCl5 is 208.22. So what I'm going to do is I'm going to say 1 mole of PCl5 over 208.22 grams of PCl5. That way the grams of PCl5 can cancel out. All right, now I have moles of PCl5 and I need to go to moles of HCl. So for that, we're going to use the balanced chemical reaction equation. So in this case, I'm focusing on PCl5 and HCl. I want to cancel out moles of PCl5, so I'm going to take the 1, remember there's an invisible 1 here, 1 mole of PCl5 and put it in the bottom. And I'm going to pick the 5 HCl, 5 moles of HCl, and put it on top. And then over here, I want to go from moles of HCl to grams of HCl. So for that, I'm going to take use the molar mass again of HCl, and this time I'm going to put the grams on top because I'm trying to get grams. And I'll put the 1 mole of HCl in the bottom. Okay? So then that way, notice how in the end, the only unit that we're left with is grams of HCl. Now I can go ahead and do my math. So what does my math look like? I'm going to do 4 times 5 times 36.46 in the numerator, all over 208.22. And when I multiply my numerator out, I get 729.2, and that's going to be divided by the 208.22, and I divide those both out and I get 3.50 grams of HCl. Okay, so we're not done because now I need to repeat that whole process, but this time for the 2 grams of water I have to figure out how many grams of HCl I can make. So if you know what you're doing, I would recommend that you pause the video and just do it on your own. And for those who need additional help, you can proceed with me. So we're trying to go from figure out how many grams of HCl we can make from the 2 grams of water. So again, we would go from grams of water to moles of water, from moles of water to moles of HCl, and then we can get to the grams of HCl. So notice that the moles have to be in the middle. Once we have that, we're going to set this up. We're going to multiply our fractions. We have 4 fractions to multiply. First fraction is our given. Second fraction is to convert from the grams of our given to moles. So for that, I'm going to use the molar mass of water, since our given is water, 18.02 grams. I'm going to put the 18.02 grams on the bottom, and then the 1 mole on top. Notice with the molar mass, there's always a 1 mole with it because that's what the molar mass is the mass for 1 mole. So whenever you're putting your molar mass in in the conversion factor fraction, make sure there's a 1 mole here. Don't use the numbers in the balanced chemical equation. Just always use 1 mole with that molar mass. All right, then I need to, so now I have moles of H2O. I need to go to moles of HCl now. So for that, I am going to use the coefficients in the balanced reaction. So the H2O, the 4 moles of H2O, I'm going to put that on the bottom. So 4 H2O goes on the bottom. And why did I do that? Remember, things have to be opposite to cancel. So now moles of H2O cancel. And then I'm going to put the 5 HCl on top, because that's technically 5 moles of HCl. Now I have moles of HCl, so I'm going to do one more step, convert it to mass. And for that, I am going to take the 1 mole of HCl, that's because that's for my molar mass, and the 36.46 grams of HCl goes on top. Okay, oops, so now we have this, just grams of HCl. And that's 36.46 grams of HCl. Okay, so now I can go ahead and multiply these out. So I'm going to have 2.00 times 5 times 36.46. And the bottom I have 18.02 times 4. Okay, so when I multiply these out and I'm going to get my numerator and denominator and divide them out, why don't you pause the video and try it yourself? So I get 364.6 divided by 72.08. And when I divide those both out, I get 5.06 grams of HCl. All right. So if this was an infomercial, that's the moment where they would say, but wait, there's more. We still haven't figured out which ones are limiting reactant or theoretical yield, but we now have the information to do so. So we know for the 4 grams of PCl5, I could make 3.5 grams of HCl. And for the 2 grams of water, you can make 5.06 grams of HCl. So which one is our limiting reactant? It's going to be the PCl5, right? Because that gives us the least amount of product. And our theoretical yield will be the 3.50 grams. So let's go ahead and write that down. I'm going to put lim R for limiting reactant is PCl5. And for the theoretical yield, I'll do Ty is equal 3.50 grams of HCl. Okay, so that is that. Last thing is they want us to calculate the percent yield, and percent yield is simple. It's just this equation here. Percent yield equals actual over the theoretical times 100, and they're telling us that our actual yield is 3 grams. So in theory, we should be able to make 3.5 grams, but we know that in real life things don't go 100% perfect. So what we are doing when we measure the percent yield is figuring out how effective was our reaction. So we're going to calculate our percent yield, and I'll do that in a different color just to make it a little easier to see. It's going to be our actual, which is 3 grams. So they have to tell you that, or unless you're doing a lab and you're actually recording that number. So that number either has to be given to you or you get it from a lab. Divided by the 3.50 grams, which is what we determine the theoretical yield to be. Multiply that by 100. So we're going to divide these two out, then times 100, and then when we do that, we get a percent yield 85.7%. So that means we're about like 86% effective in this reaction if we only made 3 grams. All right, I hope you found this video helpful. Have a quality day.